We're going to graph some linear equations that are in standard form. So we've already talked about standard form being ax plus by equals c. So when we graph these, we are going to use intercepts. So an intercept is basically the coordinate of the point where our line would cross or just touch one of the axes. So as you can see here, this is not the graph of a linear equation, but we can find some intercepts here. So this is the only point where the orange line crosses the y-intercept, or the y-axis. So it's called the y-intercept, and the coordinates of that point are 0, 3. So 0 left or right, 3 up. We have several x-intercepts, 1, 2, 3, 4 of them. So this point is -3, 0. This is -2, 0. This is 1, 0, and this is 3, 0. So what we notice is on our x-intercepts, we always have a 0 as the y value, and for our y-intercept, we have a 0 as the x value. So go ahead and identify the intercepts on this graph. The x-intercept would be -1, 0. There's just one of them this time. And there's just one y-intercept, which is 0, -2. A linear equation in two variables, again, will make a straight line. So we've practiced how to do this with point plotting. Now we're going to graph things that are specifically in standard form, which is where ax plus by equals c. A few things to note about linear equations. Obviously, the graph of a linear equation is a line. X is to the first power and y is to the first power. If you start dealing with different powers, that's where you're going to get the lines that are not linear, that will look like the W that we saw on the last screen. X and y cannot be denominators of a fraction. And for this, when we're graphing in standard form, what we're going to do is we're going to find the intercept. So we're going to use the fact that the x-intercept has 0 as a y value and the y-intercept has 0 as the x value. We're going to find those 2 points and then graph them to make a straight line. So for this first example, I've got -3y minus 2x equals -6. So someone say, well, this is not in standard form. Well, technically the x should go first. I could move the -2x to the front and the -3y after it, and now it's very specifically in standard form. But as long as the x and the y are on the same side, we can use the intercepts to find the graph of the line. So notice here, I'm going to let x equal 0. So when I let x equal 0, I'm finding my y-intercept. So I'm finding where is my line going to cross the y-axis. -3y minus 2 times 0, so I've replaced x with 0. 2 times 0 is 0, equals -6. I'm going to divide by -3 to get y equals +2. So what I just found was the point 0, 2, which is right here. That's my y-intercept. When I let y equals 0, -3 times 0 is 0, which leaves me with -2x equals -6. Oops. I divide by -2, and I get x equals +3, which I just found the point then 3, 0. So 0 for the y, 3 for the x. So that is the point right here. And then I'm going to draw a line to connect those 2 points, and that is the graph of the line -3y minus 2x equals -6 by finding intercepts. Let's do the same thing for this one. I'm going to let x equal 0. Again, if you feel better about it, you can certainly put the x before the y. Notice I kept both positive because both were positive to begin with. I'm going to let x equal 0, so 2y plus 0 equals 4. 2y plus 0 is just 2y, and divide by 2 to get y equals 2. I'm going to plot the point 0, 2 on my graph. When I let y equal 0, 2 times 0 is 0, which leaves me with x on the left and 4 on the right. So 4 is my solution, 4, 0 is the point, and I'm going to connect the dots. And that is what my line would look like. For this last one, try it on your own, then press play to see how you did. First, I'm going to replace x with 0, which gives me 4y equals 12. And when I divide by 4, I get y equals 3. Then I'm going to replace y with 0, which gives me 3x equals 12, and x equals 4. So again, these are two separate points. This is the point 0, 3. This is the point 4, 0. Then I'm going to connect the dots to make a nice straight line. Just as a side note, the only time that this will not work when it's in standard form is if it's equal to 0, because in that case you would get 0 both times, so you would have to use one of our other methods going forward. The last thing I wanted to talk to you about with standard form is that showing the work by plugging in the zeros works great, but there's also a shortcut, and in the shortcut I call it the cover-up trick, or you might hear me call it the finger trick. And essentially what I'm going to do, and again it only works when it's in standard form, is I'm going to use my finger to cover up the 3x. And when I do that, it's like me plugging in 0. So when I use my finger to cover up the 3x, the only thing I can see is 4y equals 12. And then either mentally or algebraically, I can say, well, if 4 times y equals 12, y must be 3. So that would be mentally. Algebraically, I would divide by 4 to get y equals 3. That again would find that point 0, 3, and then I would do the same thing. I would use my finger to cover up the 4y, which would leave me with 3x equals 12, which again I could think 3 times what is 12 and know that x would have to be 4, or algebraically solve by dividing by 3 and give me the same 2 points and the same solution with a little bit less work involved. So feel free to use that anytime it's in standard form. Keep in mind I gave you examples where we all had whole numbers this time. It's possible that you'll get fractions, in which case you would want to use one of our other methods.